put in chat box. So can you be with us, Professor Kozuka?
Yes. So, okay. So you mean the question in the chat box, right?
Okay, so there was a question that Rajushi asked that can you please elaborate a bit about how machine learning predicts the new material from a given structure?
Okay. So
there was a question that can you please elaborate a bit about how machine learning predicts the new material from a given structure?
So can you see my slide?
Hello.
Hello? Can you see my slides?
Yeah. We can see the slides.
Okay. So in machine learning, we don't use this complex equation. Rather, we just use these physical parameters. So in the database, we have a huge amount of parameters for many materials. And we correlate this, for example, Zebed coefficient as a function of these parameters. There may be some correlation between this Zebed coefficient and electrical conductivity, or there may be no correlation between mechanical property and Zebed coefficient. And of course, if the one parameter is strongly correlated, then we can correlate the coefficient to a specific parameter. But if the relation is quite complex, usually we cannot easily find any correlation. But if we dump this parameter and this the coefficient in the machine learning effectively finds a correlation between some parameter. The parameter could be just one parameter, but could be multiple parameter. In the case of multiple parameter, it's difficult to find correlation between this Debye coefficient of multi-dimensional parameter space. But in machine learning system, the machine learning may be able to find some correlation which cannot be easily found by human beings. That's how the machine learning may find new material for specific applications. Is that
Thank
okay?
You.
Yeah.
I think it's all okay. So there is another question for you, Professor Kozuka, that
Yes.
Okay, so someone asked that please explain about the artificial lattice.
Artificial lattice, okay. Artificial lattice is literally just this kind of lattice. So originally, if we make a bulk material, we have a single phase material. But if we use a thin film technology, such as sputtering, we can make a layer of two or three or more than one material. We can make a lattice out of from a multiple material like this. And for example, by making this kind of artificial lattice, we can create a new functionality. For example, one functionality I explained is large magnetic resistance. So in the case of, for example, iron or chromium, the single layer cannot show this kind of large magnetic resistance. But by making artificial lattice, this kind of, we can make we can create some new functionality in this kind, and we can make these devices. This is the advantage of making artificial lattice. Is that okay?
Thank you, sir. Anyone having any questions, further questions, you can also ask. By that time, there is a question for Dr. Josh. So I think someone has. Dr. Dash, can you hear me?
Yeah, I can hear.
Okay, someone asked that if the strain is generated by very sharp needle, then the polarization is generated very locally, so the current is also localized, I guess. Is it a disadvantage?
Disadvantage. It depends on like what you want to use for. So here, we just wanted to demonstrate as a proof of concept that we can tweak the quantum tunneling, and also we can calculate what's the coefficient, flexoelectric coefficient, which measures the response of any material to strain gradient at the nanoscale. So I think in this case is not disadvantages for characterization purpose, but for application, I think yes. But to apply or any material or for the application, we need to first characterize any material and choose which one is more proper to for the application. So our purpose was to develop means to characterize flexoelectricity. Is that clear, or shall I?
Think that should clear the questioner. By that time, I think someone has asked that can we create such strain by using photons to create the electric field? Means I don't know much relevant that thing.
So I mean, it's a good question, but for that you have to localize heat to very nanometer land scale. But I think it's not possible.
Okay,
So when you shine with some photon or heat, any material will transport the heat. So the temperature will be expanded. So I don't think it is a good idea.
yeah, that's I think it's fine. Anyone having any questions for our speakers? You can ask or write it in a chat box so that we can ask them or hear from them. We will just wait for some time, means if some other questions comes from our listeners. Okay, so anyone having any other questions so that you can ask our speakers? So, okay, if you do not have any questions, so I can ask one that you talked about, Professor Kozuka, you talked about the concept of GPU
Yes.
instead of CPU. So can you elaborate that thing? That's a completely new concept for us. So I'd like to hear more about this thing, how it works.
So you're talking about the GPU, right?
Yeah.
Okay. So sorry. Okay. Yeah, I'm not a GPU is not my expertise, and I'm not sure I can properly explain about it. So GPU is actually good for calculating matrix. So image processing is just matrix calculation, many matrix calculation. So some people notice that because GPU is good at calculating matrix, then it may be used to it may be applied for calculating a machine learning algorithm. That's what I understand.
Okay. Yeah, thank you. Thank you. Okay, Professor Dr. Dash, there is another question for you. Okay, someone has asked that effect you told is responsible for elastic fatigue.
Most likely not, because when you talk about elastic fatigue, we talk about some macroscopic objects, and if you basically bend or stretch it for a long time, eventually it loses elasticity, if I understand correctly. That is what fatigue is. And this is a macroscopic phenomenon, elastic fatigue. So where, as I discussed, the flexoelectric effect is very tiny. It has no effect. So I think that is not likely the case. Is that clear?
I think it's
Yeah.
clear to them. Okay, so if there is no further question, so we are almost at the verge of concluding the webinar. So I would like to thanks to our speakers for introducing us to a field which was very less known to us. And I'm sure that this lectures has surely given an impetus to our students who will be going out in these fields of research in future. Also, I hope that in future we will get our speakers and participants in this interactive modes to enrich ourselves through webinar like this. And we also hope to meet physically when this pandemic situation is over. Bid goodbye to all and have a good day. Hope you we will have you in future. And
Thank you
with
very much.
the permission of everybody, I close the session.
Thank you.
Thank you very much.
Thank you, all of you.
Thanks.
Thank you, all of you.
Very much for inviting.
Yes,
Thank you.
very nice to meet all of you.
Yeah, that's a very nice illuminating